By the end of this video, you should be able to describe the relationship between energy levels, sublevels, and orbitals, and also be able to tell me what orbitals look like. We're going to start first with the behavior of electrons. You might remember that electrons move randomly. They're very random. We don't really know where they are most of the time. We're pretty sure they're close to the nucleus, but they can be a little further out, and they could be a little further out. And because of the Heisenberg uncertainty principle, we can't really know where they are with complete certainty. We just know they're probably right around the nucleus. Okay, we do, however, know that electrons can only have certain energies, not others. They're like a car that can only go 25, 45, or 65 miles an hour and no speeds between. The electrons are stuck in certain energy levels, and they can't really pick any energy they want to have. We do know that electrons are attracted to the nucleus. It's because electrons are negative, and the nucleus is positive, and so they're going to be drawn to the nucleus. We know that electrons are repelled by each other, so if you have two electrons around the nucleus, they're both attracted to the nucleus, but they don't want to be around each other. They want to repel from each other. Right. And we also know that electrons are waves, and so they can be described by wave functions that are called orbitals. The orbital is a wave function, but it's also the place where the electron exists. It has a shape. So if we look in this picture of Mark McGwire, batting, you can see in a baseball game, the ball is most likely to be right over the strike zone at home plate. That's where the electron, for instance, in the atom is most likely to be, is right in the strike zone, right where it's supposed to be. But every once in a while, you'll have a ball, and then every once in a while, you have a wild pitch that could go like out here. Very rarely, but possible. That's kind of how electrons work. These orbitals that we're about to talk about have shapes, and the shapes, even though the electron moves randomly, we still kind of know where it's going to be. We know the shape that it's probably going to be in. It's called the probability distribution. These are the shapes. So there are three different shapes of orbitals that you need to know, but there are four kinds of orbitals that are typically found in the atom. There are s orbitals. Think S stands for sphere. There are p orbitals. Think P stands for propeller. There are the d orbitals. I don't have any clever name for d, so think d looks like a four-leaf clover. Right? So there's four of them, and then there's the one in the middle that kind of looks like a donut, doorbell, something like that. And then F's, I didn't show F's because they're complicated. All right, the deal is s orbitals, these spherical things, there's one of those in every energy level. So the way that happens is there's going to be two electrons floating around in this thing, and they're going to be moving around. And in every energy level, you'll have an s orbital where the electrons are floating around. So in the atom, here's the nucleus, and here's the 1s orbital, so there's two electrons floating around in there, and then there's the 2s orbital, and then there's the 3s orbital. Notice it kind of looks a little bit like the rings. They're not really rings. It's really that the electrons can be anywhere in there, kind of like the baseball strike zone picture. So there could be anywhere in there or even outside. It's like a big fuzzball. The p's. There are 3 p orbitals per energy level. Interestingly, though, not in the first energy level. You want to think about it. They're in every energy level except the first energy level. The first energy level might not have enough space. So here's the nucleus. There's an S. And then the second energy level, there's an S. And then the P's start going like up and down and left and right and into and out of the board, but that's kind of hard to draw. So you get this big fuzzball that has P's inside of it. The D's also are in there. They only start in the third energy level. There are no D's in the first or second, not enough space. But the D's, there are 5 of them in every energy level. Those are the pictures of the 5. Really, if you want to draw this in your notes, you just draw the clover and put times 4, because there's essentially 4 of those. There's this one, this one, this one, and this one. They're just oriented differently. And then there's one that looks kind of like the doorknob or double binky or whatever have you. All right. So these orbitals are the rooms that contain the electrons in the atom. They're the places where the electrons live. They are the spots where you're going to probably find the electron. So in the first energy level, you're going to have an s orbital. And then in the second energy level, you're going to have a bigger s orbital. And you're going to have the p orbitals. And then in the third energy level, you're going to have an s, an even bigger s. And you're going to have bigger p's. So you have the p along the y-axis, the p along the x-axis, and the p along the z-axis. And then you're going to have the D's in the third energy level too, which I could go and draw all of them, but it takes a while. All right. You might wonder to yourself, why the heck are all these orbitals having all these crazy shapes? One way to think about it is electrons repel from each other, right? So if you have a PZ, a PY, a PX, whatever have you, and you stack them all on top of each other, the electrons in each one won't interfere with the others because there's lots of empty space that they're hanging out in. So you can put 3 orbitals all on top of each other and the electrons won't repel each other as much. Same thing with the Ds. The S's, that's why only one fits per orbital. It's going to repel because there's no other way that you can fit another S there. All right, this picture on the right is here because I just wanted to point out that all these orbitals, all these shapes that we were talking about, all stack on top of each other. And when you're done, you essentially have something that just looks like a big fuzzy cloud. Hey, that's the electron cloud. We talked about in the previous video that Schrodinger came up with these models for how electrons move in atoms. He came up with the orbital idea. But the deal is, the resulting picture is just a fuzzy cloud because that's where the electrons are. You can break out the parts of that cloud, but really it's just going to look like a big fuzzball. All right, I wanted to point out that this there was a research paper that came out not too long ago, just a few years ago, that showed we actually can take pictures nowadays of the orbitals. This is the 1s orbital, this is the 2s orbital, this is the 3s orbital, and this is the 4s orbital. We can actually take pictures of them. It's really neat. In the 1930s, they came up with the equations for this stuff. In the 2010s, we actually have the experimental methods to take pictures of these things, which is really neat. They haven't taken pictures of P's yet, but we know they're there because of other experiments that have been done. All right, to recap, the first energy level only contains a 1s orbital. There's only one orbital there. The s, you can only fit one s. And every orbital fits 2 electrons, so therefore the first energy level only can contain 2 electrons because it only has the 1s orbital. All right. The second energy level has a 2s orbital, and then it has 3 2p's. Remember, there's the px and py and pz that all overlap, and so you can fit 2 electrons in each of these, and then the 2 electrons in the 2s, which looks like that. It looks like a sphere. So when you have these 4 different shapes all together, these 4, you can fit a total of 8 electrons because there are 4 orbitals. Something to point out is the 2p is called a sublevel, whereas each individual shape in there is called an orbital. The 2s is also called a sublevel, even though it only contains 1 orbital. The third energy level has the 3s, the 3p, and the 3d. An important thing to note, again, the 3 only refers to the fact it's the s orbital in the third energy level. It doesn't mean there's 3 of them. It just means there's always just one s orbital. So that s orbital contains 2 electrons. Then the p's, there's 3 of the p orbitals, but again, this 3 is the address. It's the p's on the third energy level. There are 3 p's in every set of p's. Every set of p's has 3 p's. Every set of d's has 5 d's. It doesn't matter that there's a 3 in front. The 3 is just the energy level. So there's 1 s orbital, there's 3 p orbitals, and there's 5 d orbitals for a grand total of 9 orbitals. Each can contain 2 electrons, so there's 18 electrons in the third energy level. The fourth energy level has an s, a p, a d, and an f. You might have noticed in the fine print at the bottom of 2 slides ago that there are 7 f orbitals. It kind of follows a pattern. 1, 3, 5, 7. Hey, that's pretty neat. Guess how many g orbitals there are? 9. So anyway, 1 plus 3 plus 5 plus 7 gives us the total number of orbitals in the fourth energy level. Again, it's the 4s, the 4p, the 4d, and the 4f because those are the orbitals in the fourth energy level. Again, it's like an address. It's not the number of orbitals. But 1, 3, 5, and 7 are the number of orbitals. I'm trying to do math in my head. That's why I keep talking and talking and talking. I count 16. And then there's 2 electrons in each orbital, so that gives us 32 electrons. Now you can keep doing this math up and up and up on the periodic table. As the energy levels increase, the number of sublevels increase. Notice the first energy level only fit an s, the second fit an s and a p, the third fit an spd, and the fourth fit an spd and an f. The fifth energy level, you can fit spd, f again, and also G, but G's don't exist on the periodic table. Don't need to worry about that. And every orbital, again, contains 2 electrons. So to recap, orbitals are like rooms inside the atom. Each room contains 2 electrons. The sublevels are the collection of those orbitals of all the same type. So all the P's in an energy level, or all the D's in an energy level, or all the S's in an energy level. Wait, there's only one S in any energy level. But each of those, again, is the sublevels. So orbitals are the rooms, sublevels are like the collection of rooms, and energy levels are like the floor. Thank you for watching this video.